Hello. Today I'm going to be going over oxytocin and vasopressin, both of which are polypeptide hormones that are not secreted by the posterior pituitary gland, but they are, mediated through the posterior pituitary gland. So we'll be talking about these two today, and they have a wide range of functions which we're going to delineate and compare. So first off, my slideshow will work. Here's a great overview of how oxytocin and vasopressin will be secreted. Now, as you can see, this is much different than what we had with our anterior pituitary, where the pituitary cells themselves are making the hormones. In this case, it's going to be these neurosecretory neuronal cell bodies, and this is in the base of the hypothalamus. And these are actually going to have action potentials being sent down the axon, eventually ending in these terminals that are inside the posterior pituitary gland. And it's going to actually directly release these hormones into the systemic blood. Now, as we can see, we have this systemic arterial blood coming in. This is from the heart, so it's nice and oxygenated. And it's going to mix here, get these hormones, which are polypeptide hormones, and we'll talk about that a little bit. And they're going to go through the systemic venous blood out to the rest of the body after going through, obviously, the lungs and the whole system. But that's the key change between the anterior and the posterior, is that vasopressin and oxytocin are being secreted by the neurons themselves from the hypothalamus. Now let's talk about these specific actions that these guys go through. So vasopressin has two main functions, but the biggest one being these nephrons in the kidneys. I deemed this less important, the vasoconstriction of arterioles in the body, and I'll talk about that a little more later and why that's not as big of a deal. But in the nephrons, this is going to increase the permeability to water in the collecting tubules, which will help the body retain it rather than excreting it through urine. And it's also oxytocin over here is going to do two primary things in the uterine walls and the mammary glands. So let's go into specifically the nephrons in the kidneys. Now, once these neurons send this cell, vasopressin, also called ADH, antidiuretic hormone, it's going to go through the body. And this is triggered by something that's called increased osmolarity, and that's when sodium ions are very, very prevalent and present in the blood plasma, or when the blood volume is significantly decreased. Now, when I mentioned vasoconstriction not being a big of deal, it is kind of a big deal when you lose blood, because if you contract those blood vessels, you will hopefully, with less blood volume, you will be able to continue pumping the blood throughout the body, keeping your blood pressure at a constant level, as opposed to when it gets too low, you might experience fainting. So that's why vasopressin is released during those conditions. But let's look specifically into keeping our water absorption up in response to vasopressin secretion in the posterior pituitary. This is a really specific look into what happens at the cellular level. As you can see, this is vasopressin over here, ADH, and clearly this is a polypeptide hormone, so it is only going to stay in the bloodstream and actually attach to receptors on the outside. They're not like the cholesterol steroid-derived hormones where they can actually get inside of the cell and cause nuclear changes, but these have to go through secondary messengers. And these secondary messengers, after the ADH bonds with these receptors inside of the nephrons, and these are called principal cells in the nephrons, they will increase these aquaporins that will go to the apical side where water is collected and then reabsorbed into the bloodstream. So it's a pretty nifty system here, as vasopressin is secreted, uptaken by the receptors, increases aquaporins in these cells, therefore increasing water retention. If you think of these principal cells and millions and millions and millions of them in the very prevalent nephrons, this is an incredibly efficient machinery inside of the body. So now we're going to switch over to oxytocin. You may have heard this as the love drug, but that's not actually the primary, I guess, function of oxytocin. No, instead, it's actually going to stimulate contractions in these two major female organs, the uterus and the mammary glands. Now, these two things are positive feedback loops, and that's really important to finish off, per se, these actions that they're conducting. So let's think about the uterus first. So during childbirth, this uterus will essentially push the baby out with its contractions. Now, it needs to get a signal to contract because it's smooth muscle, so it's not voluntary muscle, except when the woman is pushing as hard as she can during childbirth. But the primary way it happens is that the hypothalamus will be responding to cervical stretching, usually when the baby's crowning. So once the cervix is starting to open up, the hypothalamus will receive that message from the cervical stretching and then send oxytocin down through that posterior pituitary, once again, directly from the neurons themselves. And then oxytocin will get to the uterus, and it will help stimulate prostaglandins to be released, which prostaglandins are contractile chemical messengers, so it will allow more of the uterus to contract in tandem with itself, so it can make big contractions. And now, these are the types of contractions you'll get right at the beginning of childbirth, but we want big contractions, one that will actually push the baby out fully. So this is why oxytocin creates a positive feedback loop. If we think back to the cervical stretching, the more this stretches, the more oxytocin will be sent down. And the more oxytocin that's sent down, the more the uterus will contract, which will stretch the cervix more. And this is a positive feedback loop, continually getting stronger and stronger until birth is completed, the cervix relaxes again, and oxytocin, after that very big release, as you see your baby for the first time, which will help with the bonding process, will go back down to normal levels. Now, another major part in the female system is through the mammary gland. So during and after pregnancy, you'll experience some hypertrophy of these mammary glands and the surrounding tissues, like the myoepithelial cells. And when suckling, the baby will be stimulating the nipples, and oxytocin will be released. The hypothalamus will essentially get the signal that, hey, a baby's trying to get milk from my breast. Okay, let's send some oxytocin down, so that the oxytocin will contract these, kind of look yellow in this picture, these myoepithelial cells that will actually squeeze these cells that contain the milk in the mammary glands, and it will help secrete the milk. And once again, this is a positive feedback loop. So the more suckling that happens, the more milk will be released. And that's really important in overall life and survival of this baby. So these are amazing evolutionarily conserved processes. Now, I wanted to give you one real example of vasopressin release. And this is where I mentioned that the contraction of the blood vessels isn't as important in this case, but it's really the absorption of water and the reabsorption of water. Now, say you are a marathon runner and you are exercising outside in super intense heat, so like in Arizona during the summer. Well, vasopressin will be released in stimulation, or the stimulation being the heat, being the exercise, and that will decrease your urine production because of the water retention that's happening in those principal cells. Now, what's interesting is if you are a very well hydrated marathoner and you're drinking plenty of water, plenty of good electrolytes, this response is not instigated, is not initiated, which is interesting because most of the time you would think that this would just happen in general because you are in heat and because you are needing to sweat, that vasopressin would be released so that you can decrease the urine production and increase your water retention, but really it's not instigated when you've drank enough water. But other studies are interested in thinking of this as more of a response to your blood pressure increasing or decreasing in this case when you're sweating so much. or is it due more to the renal blood flow, so the blood flow supplied to the kidneys? So there's a lot of different trains of thought on which actually instigate this response. You know, when we're talking about these sort of automatic responses that the hypothalamus is instigating, it's really hard to pinpoint any one thing that triggers the releases of these hormones. And there's also a couple extensions of oxytocin. I mentioned earlier that it's the love drug, or purported to be the love drug. But there's also been very interesting studies in the past, like 5 to 10 years, talking about social responses and social interaction. It was found in one study dealing with an oxytocin nasal spray that in the amygdala, which is mostly due with fight or flight and like danger recognition, it was stimulated in men when oxytocin was released when the men were encountering negative social people, so people they deemed as threatening. It would heighten this amygdala response. And in the women, oxytocin actually helped with the social interaction when they saw people interacting positively with their baby, with their families. And so what's really interesting is this could be, I guess, argued that evolutionarily, men were the ones who were supposed to see the threat and attack it, whereas women really wanted this sort of pro-social behavior so that they could raise their children in a healthy and happy environment, whereas the men were more looking for, hey, I need to protect my woman and my baby. So it's really interesting that oxytocin can have a role in that. Also, some studies that were showing that sexual functioning in males, I've been talking a lot about the female reproductive system, but in males there's some evidence that the Sertoli cells that support sperm synthesis could be secreting some oxytocin that help with proper ejaculation, proper contractions of the seminiferous tubules so that the sperm gets to where it needs to be. And finally, I also want to just throw in there, in contrast with the males, this prostaglandin functioning that I mentioned earlier, where if oxytocin is released, the prostaglandins will increase in the uterine walls, thus helping contractions. And also, there's been a lot of synthesized oxytocin molecules. Since it is just a 9-polypeptide chain, it's rather easy to synthesize in a lab. And there's been some stress and social disorder studies with oxytocin and seeing how oxytocin helps people who are struggling with these types of disorders, hopefully to feel more bonded with somebody, hopefully to feel more connected. So obviously oxytocin does a lot more than just water retention in the kidneys and contractions of the uterus and the mammary glands. There's a lot more that happens in the brain with oxytocin, so that is to be determined. So I'd welcome you to continue studying that in your free time. Anyway, these are my references. Thanks for watching today, and I hope you learned something about oxytocin and vasopressin.